Welcome to this Solutions to Go course brought to you by Canyon Professional Development. This introduction to three-dimensional science instruction is Arizona specific. However, the concepts here apply no matter what state you're teaching in, as the next generation science standards are also designed in a three-dimensional fashion. My name is Marnie Landry. I am the Director of K-12 Outreach for Grand Canyon University and taught high school science for 16 years. I think this quote really kind of depicts how science was learned in the past, and maybe how you learned it, definitely how it was in my classrooms as a child, versus how we want to think about science instruction now. You can memorize your way through a labyrinth if it is simple enough and you have the time and urge to escape, but the learning is of no use for the next time when the exit will be differently placed. I know that I had to memorize a lot of vocabulary and just memorize concepts when I went to school. And when I became a science teacher, we had learned so much since then. New discoveries were made, terminology was changed to be more accurate. And so all of that memorization in the past didn't always apply to our current knowledge base or what might happen in the future. So we want to think about the skills to go through the scientific process or the engineering process to solve problems, because they're going to be different. The objectives for this course are to define the three-dimensional instruction, to differentiate between those three dimensions, to identify where those dimensions are in the current science standards, and to understand that shift from how we historically taught science to where we'd like to be when teaching science. In a moment, I'm going to ask you to pause the video and just grab a pen or pencil and something to write on, piece of paper. And I'm going to ask you to do a little drawing. I'm going to ask you to do 3 little drawings. I'd like you to sketch a one-dimensional line, a two-dimensional square, and a three-dimensional cube, just in 3 separate spots. So go ahead and pause and do that. Okay, I hope you have a drawing something similar to this. If not, go ahead and make some corrections. It does not have to be perfect. It's just a visual for you to think about while I'm describing the 3 dimensions. When talking about science and science understanding, the one-dimensional line represents knowledge. So the facts, what we have to know to understand scientific concepts. And when I went to school, this is what we were taught, the knowledge. Just what are those facts? Memorize those facts. That's the knowledge base. The 2D box, think about that as how we organize the content, that knowledge that we have, and how we think about it. So it kind of puts a frame around our current knowledge base. And that third dimension, it comes to life. It's a 3D object, that box. It's what we do with that knowledge. So we have the knowledge, we frame it and think about it in certain ways, and then we use it to do something, make discoveries, solve problems. These 3 dimensions have terms. So the knowledge, we call those the core ideas. The framing, the way we think about the knowledge, are called the cross-cutting concepts. And how we're going to use that knowledge is called the science and engineering practices. You may have seen this icon before. It is the Next Generation Science Standards, or NGSS, icon to demonstrate the 3 dimensions and how they're intertwined, how they go together. If you teach in Arizona, we have a similar, but much more detailed icon to help us think about those 3 dimensions. And it looks like this. Think of it like a layered flower. You notice there's a little disc on top, a medium one in the middle, and one on the bottom. The one on top, you'll notice, is yellow, and everything in the standards is color-coded, so it's easy to kind of keep those straight. But the yellow are the core ideas. They are the knowledge that we have to have, and there are 3 main ones: physical, earth, and life science. The cross-cutting concepts, it's the next layer down. They're the green ones. These are the frames that we're going to use to think about the core ideas. And there are 7 of them. And then finally, the science and engineering practices, the bottom part in blue, and there are 8 of those. It's what we're going to do with that knowledge. Another way to think about this is what we have to know, how we're going to think about it, and what we're going to do with it. So this flower is great to show that it is layered. They must be taught together. They're meant to be, all together. Just think about spinning the parts of the flower to line them up. What we need to know, how we got to think about it, and what we're going to do. But it can be really hard to work with. A little difficult to read, a little difficult to find how they align. So there's a fantastic document on the Arizona State Science Standards site called the AZSS Snapshot. I call it the Do, Know, Think document. If you'll go ahead and pause the video, and you can find a link to this document on the handouts in the course. So go ahead and pause and pull that up. I like to keep this handy when I am writing a science lesson or a unit, or just trying to find a standard, because it helps me think of the 3 layers, and it's easier to read. You will notice in the document you pulled up, there is a purple box in the bottom right that I do not have here. I will not be getting into that one, but it is the 4th part of our state science standards, the using. You'll see there's a U1, a U2, and a U3. Most of your standards will be U1. So scientific phenomena, seeing a phenomena, performing experiments, and understanding that phenomena. That's for a different course. I recommend you print this out and keep it in your lesson plan book, whether or not you have fully adopted the 2018 science standards. It is very useful for thinking about how to plan a lesson, an engaging lesson. Speaking about engaging lessons, in a moment, I'm going to ask you to pause again, and I want you to think about the best science lesson that you ever taught, or you experienced as a learner, or you witnessed someone else teaching, maybe when you were a student teacher. Just think about that incredible science lesson and jot down a few thoughts about what made it the best. What was it about it? I'm guessing there aren't notes on your paper that explain that the lecture was organized and the students all took notes. I'm guessing that you didn't write anything that all of the students got the same results for the experiment. The best lesson probably was engaged by everyone just turning in their work. What is it that makes it a best lesson? Well, it kind of depends on your perspective. Is it as a student or is it as a teacher? But there was probably something about it that was engaging, that the students were excited and couldn't wait to see what was going to happen next. They were having some kind of fun. From a teacher perspective, maybe it's because all of the students were able to pass the quiz or the test that was about that concept. From the teacher or the administrator's perspective, maybe it directly addressed the standards. That's always a sign of a great lesson. It was authentic. They were doing real science and engineering. The students really learned. So without even knowing necessarily too much about three-dimensional instruction, these are all aspects of it. Three-dimensional instruction can accomplish all of the requirements of a best lesson. It's one where students they witness a real phenomena, something that really happens in real life. They get to ask questions. They figure out answers to those questions in a variety of ways. Maybe they design solutions or they design experiments. They go through research and modeling. They get to argue from evidence. They collect evidence and then present that evidence. So three-dimensional instruction should be able to address all of those things in the best lesson ever. So here is an example of science standards in the previous format we had in Arizona, 2005 on the left, and the same concept on the right from 2018 science standards. They're both life science and they both have to do with kind of life cycles and requirements of life. I'm going to ask you to, in a moment, pause the video. When you pause the video, I'd like you to read both sides, the 2005 version of the standard, and on the right, the 2018 version of the standard. And then you'll notice it says, discuss and answer questions, set A. On your discussion sheet handout, that looks like this, I've repasted those two standards, 2005 on the left and 2018 on the right. And then down below is, so question set A, compare the previous standard to the current standard. So looking at the 2005 on the left, for number one, record the verbs that you see in this standard, which is the bottom box. And on the right for the 2018, record the verbs you see in the bottom box. And then I want you to record what you think students should know just by reading those. What does the standard tell you that students should be doing? And how will students demonstrate their thinking? And finally, any other similarities or differences, go ahead and record those below. So this will take several minutes. When you're done, please come back. Welcome back. I'm guessing you noticed some differences. If anything, the 2018 one has a lot more words in it, right? Did you notice that there was a little more direction? There was a little more framing in the current standard. The teacher has a better idea of what students should be doing, what they should be looking for. Gives a little more concrete wording that directs the activity or the lesson. I hope you noticed there were many more verbs, things for students to do. You may have also noticed on the right where it says cross-cutting concepts, there are several listed. I'll highlight them here, but two of them were bold. When you read the standards, you will notice on the right-hand side in the standard document that you'll see several listed, but a few are bold. The ones that are bold are considered foreground, meaning these are the ones that should be focused on during your unit or your lesson that you design. The other ones can still be used and addressed, but they're not as prominent. So it's not wrong to ask students to look through the lens here, like of cause and effect. But really the best way to communicate and think about this issue is systems, system models, and energy flow. That's really the focus of the standard. So just notice those bold ones are foreground and really should be the focus of the unit. All right. going to ask you to pause again and do this almost the same thing, but this time I want you to choose a standard that you either normally teach or will be teaching. That last one was a second grade life science core idea 2. I want you to just flip through the standards and find one that you will teach, one that you're kind of familiar with the content, and almost do the same thing. You can find the link to the Arizona State Science Standards in the syllabus and in the documents. And then I'm going to ask you to discuss and answer question set B. So on the discussion questions, if you just scroll down, question B. Oh, and I've linked the science standards here as well. So I want you to go and find your choice, paste it here, and do the same thing. Just identify what students need to know. What are the facts that you have to make accessible to them? What shall they be doing? And how will they demonstrate that thinking? What lens or what frame are you going to help them process that information through? Let's go ahead and pause and come back when you're ready. Welcome back. And I hope that you were able to find that they're very clearly written, what students need to know, how they need to think about the concept, and what they need to do. Very useful if you are designing your own lessons or your own labs or your own units, or if your school or district already has curriculum purchased, to make sure that you're looking for these 3 dimensions in the lessons they're providing. And if they're not, that you may need to supplement to make sure that the lessons being taught are well-rounded and they're not just fact memorizing or not just playtime. As you looked at the 2005 standard or whatever standards you were used to compared to the new ones, there are some things, there's a shift. We're looking for a shift, and hopefully there should be less of just this giant list of vocabulary that are disconnected from any authentic experience. Teachers, you should no longer be the sole source of facts. Students need to be able to access resources. They need to learn how to make decisions about what resources are reputable and which ones are not. Not always asking questions that have one right answer. Students need to have some time to process information and build ideas, and even express those ideas that are incorrect so you can understand their thinking and you can help redirect to the proper understanding of the scientific concept. So think about questions that can promote discussion or probing questions as opposed to what's the right answer to this. Reading the textbook and answering the questions at the end is not scientific instruction. The textbook and the questions can be a resource. They can be review material. I'm not saying to not use them. I use them all the time. But they should not be the curriculum. They are not 3-dimensional instruction all on their own. Piles of worksheets. How can you do science when you're filling out a worksheet all the time? And finally, we want to see less of oversimplifying for students that we think or perceive not able to do authentic science and engineering. They are all capable of doing some type of authentic science and engineering. What we want to see more of are thinking in systems. Students getting the opportunity to explain how they think a phenomena is happening, letting them build on that explanation. Students investigating those phenomena, solving a problem in creative ways, maybe coming up with different ways to solve a problem. discussing their ideas with other students, asking and answering open-ended questions and using evidence. So supporting their claim with evidence. This comes from teaching them how to use resources and how to choose resources. Using multiple resources, not just one. We know that sometimes, depending on the age of your resource, it may have been eclipsed by new information. Writing, students need to be writing. They need to be expressing their learning and their understanding, not just verbally, with images, with diagrams, and in written format. And finally, providing supports so all students can experience authentic science and engineering. So as we look back at the 3 dimensions, they are the core ideas, the cross-cutting concepts, and the science and engineering practices. And they are intended to all be taught together when learning scientific content, not just memorizing the facts. That doesn't mean that you can teach what each of the science and engineering practices are separately, so students understand them when you go to ask them to analyze data. You might have to teach that skill first, but you don't separate it out when you're doing the authentic science or teaching the authentic lesson. Same thing with the cross-cutting concepts. You can definitely teach what it means to look for cause and effect and what is actual cause and effect and not just correlation. So you can teach that separately, but when you go to teach the science concept or the core idea, these are all taught together. They're layered like a flower. And again, that first dimension is just the knowledge. What do we need to know? The second dimension is the frame. How do we need to think about it? And that third dimension is action. It's what are we going to do with that knowledge? Canyon Professional Development is here to empower, educate, and inspire you, our community, so you can take action to fulfill your purpose and serve others. We'd like to remind you that we have a YouTube channel with hundreds of videos just for teachers, either tech tips, webinars with experts, or pedagogical lessons on how to support you in the classroom. And finally, we'd love for you to connect with us on social media. We are everywhere and are often putting out resources for teachers and highlighting the great work that you do. Thank you, and I look forward to you joining us for another Solutions to Go course.